Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking over lessons 9.4 through 9.6 from your textbook. We're on page 520, looking at 17 through 37, so that goes to page 521. And let's start here. Find the tangents of the acute angles in the right triangle. Write each answer as a fraction and as a decimal, rounded to 4 decimal places. So for number 17, I'm going to kind of draw some lines here so we can separate these three. We're going to find the tangent of J and the tangent of L, since those are my two acute angles. Tangent J is opposite over adjacent, so 11 over 60, and that decimal is going to bring me 0.1833. Tangent L, opposite over adjacent, is just the reverse of that, 60 over 11, which is 5.4545. Okay. For number 18, I have tangent P. Opposite is 35. Adjacent is 12, or 2.9167. And then we've got tangent N. Tangent N is opposite to adjacent, so 12 to 37, or 0.3243. And then over here, we had to do a little extra work for number 19. The tangent of A, we'll start with that one. Opposite is 7, adjacent is 4 square root 2, but you can't keep your square root 2 on the bottom. So we multiply square root 2 top and bottom, so we're going to get 7 square root 2 over 8. And that decimal is 1.2374. And then we also have our tangent B, which is just the reverse of that, 4 square root 2 over 7, or 0.8081. Okay. Next up, we have finding the value of x. So this is when we are still going to be applying tangent, because if you look at x is directly across from tangent, and we're still using that other leg. So for number 20, we're going to do tangent 54 degrees is equal to opposite x over 32. So essentially, to find my answer, I'm just going to multiply both sides by 32. Okay, these 32s, should have put that up here, will cancel out. So I'm doing 32 times tangent of 54 degrees will give me x. Once I type that into my calculator, rounding to the nearest tenth, I'm just going to get x is equal to 44.0. Next up, I've got 21. Tangent of 25 degrees is equal to opposite x over adjacent 20. Again, to solve for x, I'm going to multiply both sides by 20. On the right side, those 20s cancel out, so 20 times tangent of 25 is equal to x. Rounding that is going to give me about 9.3 to the nearest tenth. Okay. And then finally on this page, 22, I've got tangent of 38 degrees is equal to opposite 10 over adjacent x. In this case, to start solving for x, I want to get x to a numerator, so I'm going to multiply both sides by x. Unfortunately, x does not cancel out when we do that. We have x times tangent of 38 and then equals 10. So in order to find my answer, I'm going to have to divide both sides by tangent 38. Okay. Since tangent of 38 is going to give me a wacky decimal, and I don't have the super intelligent calculators in my hand, I'm just going to find the decimal of tangent 38. That's going to give me about 0.781285. And then I'm just going to take 10 and divide it by that number. So x just rounds to about 12.8. Okay. 23. This angle between the bottom of a fence and the top of a tree is 75 degrees. Again, noticing we are still given our two legs, so because we're given legs, we can use tangent. So I'm going to find tangent of 75 degrees, which is opposite x over 4 feet. So to find my answer, I'm just going to multiply both sides by 4 to get x all by itself. So 4 times the tangent of 75 degrees will give me whatever x is equal to, and that'll round to my nearest foot of about 15. So x is equal to 15 feet. 24 is when we're going to talk about our sines and cosines. Now, the nice thing about sines and cosines is they can be interchangeable with the opposite other acute angle. So, for example, for number 24, the sine of x is also going to be the cosine of z. So we can technically knock out two birds with one stone. So if I'm finding the sine of x, remember sine is opposite over hypotenuse, so that's 3 over 5. And we can keep this as a fraction, or if you want to put it as a decimal, round it to 4 decimal places, 0.60000. So the sine of x is the cosine of z, because cosine is adjacent over hypotenuse. So just to recap that, z's cosine is 3 adjacent, hypotenuse is 5. So sine of x was done. Now let's do cosine of x. If I have cosine of x for number 24, then that's also the sine of z. Okay, so cosine of x, adjacent, 4 over hypotenuse 5, or 0.8000. Okay, so again, you don't have to calculate 4 separate things here. You're just calculating 2 things and finding the things that can go together. All right, so 25, let's start again. Sine of x is also the cosine of z. Sine of x, opposite over hypotenuse, that's 7 over square root 149. But we got to multiply both numerator and denominator by 149 because we can't have that radical on the bottom. So I'm going to get 7 square root 149 over 149, and then that decimal is just 0.5735. Okay, then I've got my sine of z is also the cosine of x. Sine of z, that's opposite over hypotenuse, or 10 over square root 149, but again, can't have that, so we're going to multiply both top and bottom by 149, so that'd be 10 square root 149 over 149, which rounds to about 0.8192, fourth decimal place. Okay, and then last but not least, we have 26 here. The sine of x, we'll start there, is the same thing as the cosine of z, so that'll be opposite over hypotenuse for x, sine 55 over 73, which decimal 0.7534 rounded. And then the sine of z is the cosine of x. So sine of z, opposite over hypotenuse, 48 over 73, or 0.6575. Okay? Up next, find the value of each variable. Using sine and cosine, round your answers to the nearest tenth. We're going to start with the sine of 23, because sine is going to be opposite over hypotenuse, so t over 34, and I'm just going to multiply 34 and sine 23. I'm going to get t is approximately 13.3, rounded to the nearest tenth. Then I'm going to find the cosine of 23. Cosine is adjacent over hypotenuse, so s over 34. Again, multiplying 34 times the cosine of 23, s is approximately 31.3. Okay. 28. Sine of 36. Let's start there. Sine of 36 would be my opposite over hypotenuse, so s over 5. Again, we're multiplying 5 times the sine of 36, or s is equal to about 2.9 rounded. And then cosine of 36, that's adjacent to hypotenuse, so r over 5. Multiplying 5 times the cosine of 36 will give me r at right about 4.0. Last but not least, we got our 29 here. Let's do our sine of 70. That is opposite over hypotenuse, so v over 10. So we're going to be multiplying 10 times the sine of 70, so v is equal to 9.4 rounded. And then cosine of 70 is equal to adjacent over hypotenuse, so w over 10. Again, multiplying 10 times cosine of 70, we're going to get w is about 3.4. Okay? Last little bit. writing sine of 72 degrees in terms of cosine, this is where you would just subtract 90 from 72, and that's the complement. So we would get cosine 18 degrees. That's all you got to do there. And then writing cosine in terms of sine, again, taking your 90, subtracting that 29, we're going to get 61, so this is sine of 61 degrees. Okay? Last bit, let Q represent an acute angle. Use a calculator to approximate the measure of angle Q to the nearest tenth of the degree. For 32 through 34, this is when you're going to be using your inverse, okay? So 32, meaning I'm taking the inverse of cosine and finding 0.32, and that'll give me about 71.3 degrees rounded to the nearest tenth. For the next one on 33, the inverse of sine of 0.91 is about 65.5 degrees rounded. And then tangent inverse of 0.04 will give me about, small degree, 2.3 degrees. Okay? Finally, for 35 through 37, we're going to be looking at finding everything from this right triangle, so angles included. I like to start with sides, so I'm going to start here. X squared plus 10 squared is equal to 15 squared. So x squared plus 100 is equal to 225, or x squared is equal to 125. So x, or, well, in this case, we'll just call it BC since that's the length of the side I'm looking for. Rounded is about 11.2. Okay? The next thing I can do is just use my two givens. So I'm going to focus on angle A. And angle A, I'm given my adjacent and hypotenuse. So that is cosine of angle A. Can be found by using 10 divided by 15. Remember, this is taking your cosine inverse and whatever 10 divided by 15 is as a decimal. And you should get about 48.2. So angle A is 48.2. So angle B is just easier to find. I can find angle B by doing 90 minus 48.2, and I'm going to get 41.8. Okay, so I found all my angles and my missing side. For number 36, I am missing a leg, and I'm given my other leg, so that means I can probably use tangent of 37. So let's say tangent of 37 is equal to opposite x over adjacent 6. So I'm going to multiply 6 times tangent 37. So this x, which is ML, is equal to about 4.5. Okay, and then NL, I can maybe do cosine, which would be adjacent over hypotenuse, so cosine of 37 is equal to adjacent 6 over don't know hypotenuse. That means I'm going to be multiplying both sides by x first. So x times cosine of 37 is equal to 6. Then I finally just have to divide both sides by cosine of 37. And I'm going to come up with that decimal of 7.5. So this is NL, my hypotenuse, 7.5. Okay? Could have also used some Pythagorean theorem. To find my angle L, that's very easy. I just do 90 minus 37, and angle L is going to be 53. Okay? So I got my side lengths and my angle. And then my final question, number 37, to start off, I'm just going to do x squared plus 18 squared equals 25 squared. I'm going to get x squared plus 324 equals 625. Subtracting those, I'm going to get 301, and then the square root of 301 rounded is about 17.3. So xy, 17.3. And then to find my angles, I know that my angle x will do that one. I can see the angle x in comparison opposite to hypotenuse is what I'm given. So that's my sine of x is equal to 18 over 25. So I'm just going to use the inverse of sine to find my 18 over 25 ratio, and angle X would be 46.1. So to find angle Z, I just take 90, subtract 46.1, and angle Z is 43.9. Okay, it's kind of squished in there, but there we go. That'll conclude our review on chapter 9's second part. So 9.4 through 9.6, this is basically your sine, cosine, tangent, and then solving anything with the right triangle. Hopefully this video helped you. If it did, give it a thumbs up, and good luck on your quiz tomorrow. Have a great day.